So last time we did a hypothesis test for mean, specifically population mean. Now it is proportion. The process is exactly the same. Instead of using mu, you'll be using p. P is a proportion, so the value of p, whatever you have in the problem, has to be, it should be a percent, it should be between 0 and 1. So mu could be any value, but p always between 0 and 1. The very first step, we write the claim. Same as always, no alternative. As an example, what type of test is this?
Two-tail.
It's a two-tailed test of proportion. And what is the value that we are testing for?
P.
P
Is there no value?
equals 0.5. So, or not equals 0.5, depending on the problem. But the claimed value is P naught. If P is 0.5, what is Q? 0.5. Q is 1 minus P. In that example, it is still 0.5. So, step one, the definition is the same. The difference being, instead of using mu, we use p. The next difference is in the test of distance. Last time it was x bar minus mu divided by s over square root of n. Now p hat minus p divided by square root of p times q divided by n. P is known 0.5, same as p naught in that example. What is p hat?
Up the
Yes. Specifically.
population proportion. One.
P hat. Anytime there is a hat,
Proportion. Okay, never mind.
Is it the successes? Like success versus failure thing?
right, but what's the difference between P hat and P, Matthew?
It's the same proportion versus population.
This is the sample proportion, that is the population proportion. Or, as Talon pointed out, is too blue. It is an estimator. And some mentioned the number of successes. This is what she was talking about. X divided by n, where x would be the number of successes. What is n?
The number of
Sample
trials.
size.
Sample size, the total number of observations that we have. Last time, what distribution did they use? T. Do you want to take a guess as to
chi-squared,
chi-squared,
that's another distribution.
yes, but do you see a square somewhere?
No. So you square root, but never mind. Normal.
No. I used the letter Z. Mean 0, standard deviation 1. So from this point forward, everything else is the same. Drawing the rejection region on the right, left, both sides, finding the critical value, finding the p-value. The difference being, instead of using a t-distribution, we're going to use a normal distribution. So instead of using TCDF, we will use
PCDS.
BCDF,
Normal.
normal
Oh,
CDF.
and so
Instead of using inverse T, we would use
Inverse normal.
inverse norm.
I see.
Good, that's it. So with the test for mean, we wanted the population to have a normal distribution, in the sense no bias whatsoever. Here we have an assumption more like a condition. N times P and N times Q must be at least 5. Otherwise, you cannot use this test. You won't get the correct answer in terms of interpretation. So we need N times P to be bigger than or equal to 5, N times Q at least 5, both of them.